Shrinkage is a change in size. It is a characteristic of all plastics and occurs when plastics cool from liquid to solid. All injection molding components are subject to shrinkage to varying degrees. It cannot be eliminated, but it can be minimized and controlled. There are many different factors that affect how plastics shrink. Some relate to the chemistry of the material. Other factors relate to the additives in the polymer and to the processing conditions used to mold the parts. To mold parts with accuracy, it is important to understand shrinkage behavior. The polymer's properties are determined when the polymer is manufactured and govern how the material shrinks as it cools from a viscous liquid to a solid. All polymers shrink differently. A semi-crystalline material shrinks very differently from an amorphous material. Even different grades of the same material shrink differently. Semi-crystalline materials shrink much more than amorphous materials. As the polymer cools, some molecules form crystalline regions. This allows the material to fit together more tightly. Therefore, the material becomes denser and shrinks more. The shrinkage of polymers in amorphous materials is restricted by chains running in other directions. The extent to which a material shrinks, or changes in volume between liquid and solid states, is referred to as its volumetric shrinkage. Plastics can shrink up to 25% during the injection molding process. However, plastics are compressible. When you apply pressure to a liquid plastic, you can compress the molecules into a smaller volume. In injection molding, you can then inject more material into the mold. Adding this extra material compensates for the shrinkage that occurs. When plastics are injected into a mold, they are subject to a new set of conditions that affect how they shrink. Plastic molecules tend to align themselves in the direction the polymer is flowing. This alignment, called orientation, influences how polymers shrink linearly. Many polymers shrink more in the direction of flow and less perpendicular to the flow. How much they shrink depends, in part, on the characteristics of the polymer, additives in the polymer, and the processing conditions used to make the part, including temperatures and pressures. You can minimize the effects of plastic shrinkage early in the product design cycle by using Moldflow Insight. By setting up and running an analysis, you can view deflection results, which help you visualize how far points on the part move from their original locations. If you have difficulty viewing the result, you can scale it so it's easier to interpret. You can also constrain the result to show shrinkage in a single axis. The Examine Result tool is useful when paired with the deflection result. You can identify individual points and display their coordinates before and after shrinkage to see how far those points have moved. Then, you can alter the processing conditions or redesign the part or mold to change the shrinkage that you identified using this result. One potential solution is that the size of the mold could be increased to account for the specific shrinkage figures identified by the deflection result. So now when the part shrinks, it's within design specifications. If the cause of shrinkage is material-based, a substitution is required. You can consult the material database within Insight to find an appropriate replacement. The database provides information on a material's shrinkage properties and recommended processing conditions. You can search the database and display a side-by-side comparison of potential materials, so you can find the most appropriate match, and then run the analysis to verify the new material's suitability. Plastic shrinkage is unavoidable, but understanding how and why plastic shrinks, and what to look for, is an important step towards controlling the effect it has on a part. The tools available in Insight not only identify shrinkage, but they help you design solutions based around principles of plastics and mold design. But what if different regions of the part shrink differently, causing the part to change shape? This concept is called warpage and is explained further in the next video.